Okay, hello everyone and welcome this fine morning to the Bow Valley Sustainable Building Summit. My name is Jody Connual and I'm a program coordinator at the Biosphere Institute of the Bow Valley, and I will be your host today. Before we get started, I just wanted to go over a couple of housekeeping notices. So as webinar attendees, you will not be able to unmute your microphone or turn on your video without permission. However, we do welcome active participation at these events. So if you have any questions for either Matt or Bilal, please just type them into the Q&A box using the bar at the bottom of your screen. And they're going to try and answer questions as they come in, but there will also be time at the end for additional Q&A conversation. If you're experiencing technical difficulties, please either reach out to me privately in the chat function, or you can email resource@biosphereinstitute.org. I will put that into the chat so everybody's got access to it, and I'll do my best to facilitate an answer to your question. So the Bow Valley Sustainable Building Summit's been brought to you today by the Biosphere Institute of the Bow Valley and the Bow Valley Builder and Developers Association. The Biosphere Institute is a local Canmore-based charity that aims to address what we believe are the two major challenges affecting the Bow Valley today, one of which is human-wildlife coexistence and the other is climate change. Our climate action efforts are managed under the Bow Valley Shift program, where we try to promote local action and engage businesses and residents to reduce their energy emissions, waste reduction, and water use. The Bow Valley Builders and Developers Association is a membership-driven networking and advocacy group. BODA keeps its members up to date on issues impacting the industry and our local community. BODA luncheons are, pre-COVID of course, have been the premier monthly business networking event here in the Bow Valley. We'd also like to thank the generous support of Energy Efficiency Alberta and the town of Canmore, with whose support the Biosphere Institute spent 6 months in 2019 talking to local businesses and trying to find out what they really wanted to learn about energy efficiency and how they best wanted to learn it. The result was a Sustainable Building Summit, and due to COVID-19 pandemic, we decided to take the event online, and that's how we got here today. So now I'm going to introduce today's presenters, Matt Grace and Bilal Maroof of the Integral Group. Matt is very well known in the green building industry for his advocacy of sustainability. He has over 25 years of experience, and in 2017 was recognized as one of the most exceptional professionals in the green building industry and honored with the CaGBC's most prestigious designation award as a lead fellow for his significant contributions to the green building community. Matt's work and credibility in the industry has been proven time and again by his outstanding leadership. Bilal is a mechanical engineer who specializes in high-performance building design and energy modeling. He has over 5 years' experience in the assessment and optimization of building systems, particularly with the aim of achieving near or net zero targets. His most recent project involved the techno-financial study of net zero buildings across Alberta for multiple building typologies. So without further ado, I'm going to hand over the reins to Matt and Bilal. Please take it away, guys.
Alrighty, good morning, everyone. Good afternoon or good evening, wherever you are around the globe. Thanks for your time to join us today in this rather good webinar. And Jody, thanks again for the rather flattering introduction. We thank our sponsors again, and we hope that today's webinar will be very fruitful to you. As Jody indicated, Matt and myself are more than honored to answer your questions as they come. So please feel free, this is a dialogue. If you have doubts, questions, or critiques, we're all ears, and we're gonna head start. Maybe before I begin, Matt, do you want to say a few words?
Yeah, let me kick up. So we're going to do a bit of a double act here, and we're going to do a bit of sharing here. So I think it's really amazing that Jody's been able to pull this event together, and it's one of the positives coming out from the pandemic is that we can do such things without leaving our bedrooms if we don't want to. So the plan is, I think, Bilal, I'm going to kick off here on the next few slides. So we'll click straight on to the agenda and the learning objectives. So really the context for this has been inspired that seeing that there is actually more than one way of looking at net zero. So the first thing that we wanted to tackle here in this agenda was really recognizing that there is more one way to look at net zero. You know, there's primary energy, secondary energy, there's carbon, there's annual, there's off-grid. There's lots of different ways. And before, just like any other element of sustainability or any other actually element of building design, it's not a bad idea to start off making sure you know what the target is and you have a clear definition of what you're trying to do. So we wanted to have that as a recognition, just in the same way that, you know, if you're doing a living building challenge project or a LEED project, let's make sure you know which version that you're actually targeting first. Then we also wanted to recognize that we live in a special place with a special climate, and it's probably one of the hardest places to design buildings for, with the extremities of weather that we get. So we wanted to recognize that, and we have some very special challenges in Alberta. We want to try and do a little bit of crystal ball gazing and look at the NECB 2020. So part of this is driving movement towards net zero buildings through legislation. Part of it is driving it through demand. And I think you need a bit of both. We can never hope for legislation to completely replace everything. Then we wanted to look at what happens. 99% of people think that climate change is a real thing. One of them happens to be orange and south of the border here. But the vast majority of sensible people have recognized that climate change is a real thing. So what does that actually mean to how we design our buildings, and what does that mean to how much energy they're going to use and how much carbon they're going to be putting out in the future? And then we also wanted to kind of touch on this idea that how does it actually affect the performance of a building for the people inside? So what happens to the indoor air quality and the health, which with the pandemic is becoming even more necessary? Anything you want to add into the agenda there, Bilal? Any subtleties I missed out there?
No, I think that makes a lot of sense. We will touch on a little bit with the costs, because that's always the elephant in the room. Developers and designers alike would like to know how much does it cost, and it will be to people's surprise that usually it's not really the biggest investment you make. In fact, it makes a lot of sense in returns on investment. So we'll touch on that as well.
Okay, so if that also, I like to do a very clear setting out of expectations. So if you've accidentally come into the wrong seminar, then we won't be offended if you leave at this point. If you leave halfway through, I will be disappointed. But if you thought you've come into to something completely different, then now's your time to exit if this is not what you're expecting. As Jody said, we actually would love to see questions coming through. We've got an hour, and we could either just kind of plow through it and deal with the Q&A at the end. But if people do have burning questions, we'll do that as well. We've just got 2 slides, just if you haven't heard of Integral Group. I do get slightly offended when people do these agenda sounds great. Good, thank you. Laurie said that. I do get slightly offended when people end up treating these seminars and webinars as a bit of a promotional activity. But so I've just got 2 short slides. Integral Group is a company that was set up to specifically address high performance buildings and net zero buildings. It's an international company, been around 15 years now. And the mandate is deliver high performance buildings, deliver net zero buildings. Lots of very smart people, way smarter than I am. And we've got offices around the world, big presence in Vancouver. And then if just click on the next slide, Bilal. We kind of do everything in terms of green buildings related to mechanical, electrical, obviously all the sustainability, the energy modeling is a big thing. And all those kind of key items. I don't think we need to add anything there, do we, Bilal? So in a minute, Bilal's going to share a piece of important research that we uncovered, and there's actually a few hidden messages in this. So I'll see if anybody we'll just put this one up and give you maybe 20-30 seconds to read this next graph and see if any questions arise from this. So what you'll see from here, this is a good case study. We've got an independent reference. I'm doing my good practice. I've got my scales, my X and Y. And who can spot a problem with this here? Clearly, they haven't calibrated the number of pirates that are leading to the change in global average temperature. So clearly, this information cannot be trusted. So you all spotted that. Pirates, yeah. So I like to put this one up because I came across this by accident. And if you are bored at home and you need a break and you don't want to leave your screen, these are the guys behind the spaghetti monster and the religion called the what are they called? The Pastafarians, isn't it, Bilal? So these guys.
Interesting name, yeah.
These guys believe that the world was created by the flying spaghetti monster, and they're all Pastafarians, and they have the right, as part of their religion, to wear colanders on their heads. And so he just put this up as a bit of a spoof. But the reason why I like this one is because when you're trying to promote a green building, you will find you have a mountain of suppliers telling you that their solution will give you a green building. They say, if you put this pump into your building, it will make it greener, it will make it more efficient. And you need to be very wary of the data. Sometimes you'll find information is coming through and there are no scales on it. Sometimes they're not referenced. So it's just a bit of a warning that you need to be fairly cynical of the data. So obviously you want to check you're all awake. So, okay, I'll let you just soak this one in for a second. What we wanted to do with this rather busy graph, this table, is just highlight 3 of the main ways we're seeing of defining net zero. And when you're starting out on a net zero project of any type, as we said in the agenda, is the first question I would like you to ask or recommend you ask is, what version of net zero would you like? And the 3 that we're seeing there is kind of coming in as kind of being most prevalent at the moment in the Alberta market is one is the CaGBC have their own zero carbon standard, and they've just released, I think, Bilal version 2. Is that correct?
That is true. Just beginning of this year. Yep.
So there again, if this is what your client says they want, then you need to say, okay, well, we're now just in version 2. So this is obviously the same people that brought you LEED, and they've done a really good job of presenting something that's pretty clear and very well defined, but also I would say it's kind of the market-friendly version of net zero. The 2 things I will highlight for you are 3 and 4, if you're not familiar with this. Number 3, which is quite surprising when you first look at it, is it recognizes that you only need to meet this certification. It is a third-party certification of 5% of the modeled annual energy. There is a version for existing buildings as well. And then the second one, which is quite a challenging target, is the TEDI. So if you're not familiar with TEDI, which I'm sure you are, that's something to wrap your head around. And the TEDI target for most of our climate zones is in that 34 to 36 range. So that does require a very significant envelope. The second one that we're coming across is from ILFI, which are the same people that brought you the Living Building Challenge and other things. And they're actually sometimes asking for net positive now, like you'll actually generate 105% of the building needs. What's interesting for me about the ILFI approach is that they actively encourage you to look at the idea of looking wider than one individual building. So they actively promote the idea to say, well, look at adjacent buildings and look at adjacent resources for putting in renewables. The other thing that's quite interesting and potentially not great for people in the business of energy modeling like Bilal is that they don't really care how you've modeled it. This is they just say, well, come back after a year and give us 1 year of bills after you've occupied the building. So that again, these first two are kind of third-party certified. And then the other one I wanted to highlight is this idea of net zero energy ready. And I'm a big fan of this. So what we do is we say, well, maybe a client isn't absolutely prepared to commit to net zero. So what we do is we design a building that has the incorporation of, for example, PV solar on the roof integrated into the design. So the architect will be happy. The structural engineer doesn't need to come back and check something. There's a space for the conduit. We know where the inverter is going to do. And we say, okay, if we accommodate this part of the area of the roof area with PV solar at some point in the future, this building is capable of being net zero energy performance. Did I miss anything there, Bilal? Did you want to add anything?
I think, Matt, you got it totally right. I would just add my 2 cents here. As I say, the devil can be in the details, and that goes the same for which net zero standard. So as Matt explained, each standard or rating system could have a bit of a different definition. I want to give an example differentiating the zero carbon versus passive house. Passive house is widely popular becoming these days, and people are familiar with it. While passive house does require a specific EOI or energy use intensity to be met, you will realize that in the zero carbon standard, and point number 5 here, it only says report. So we have all the flexibility for how much the building in a way or another would consume, but you only need to meet the thermal energy demand. So just looking at that, it will really depict where you spend your dollars when you're investing in a building that is net zero. So just to reiterate what Matt said, I think the designer and the owner should really be on the same page of what's happening and how should that rating system be achieved. I would jump to the next slide here. Feel free, Matt, to explain that, but I guess
Sure.
we don't want to go into the depths of every single row here. But the message is, just like the 3 different alternatives we showed in the previous slide, there are, across Canada at least, I should say, many other frameworks and pathways to different high performance standards, or sometimes authorities having jurisdictions requiring the buildings to be met at a specific performance, just like the BC STEP code and the Toronto Sustainability Guidelines, and etc. So Matt, feel free if you want to add a few words here as well.
Yeah, thanks, Bilal. This again is another rather busy slide, but that's really the intention of it. So this is from the results of one of the studies we recently did for Alberta infrastructure on achieving different versions of net zero. And there is actually a bigger table with I think about double the number. And again, the message is make sure you know what your target is. And then as just to reiterate what Bilal said, is sometimes the devil is in the detail. So maybe achieving that particular energy use intensity or the TEDI as required is quite important. And there is also, which doesn't appear on here, just the very basic idea that net zero is a building when you model it generates at least as much energy as it's using. So it is coming into funding. We have seen that on a few projects. And the first thing I do when I get asked a question is I say, send me a copy of the funding requirements, please. I want to see them in my own eyes and check that we know what we're doing. So I'm going to do one more slide in just a second. And I'm just going to, before Bilal clicks onto the next slide, I recognize a bunch of the names on the participants, and there's some very significant names on there. Feel very honored. One of the things that I like to just ask you to think about is the role of the built environment in tackling climate change as a whole. So if what we have on the next slide is a graph produced by the International Panel on Climate Change, and it's the potential greenhouse gas emissions reduction by different sector. So you don't need to worry too much details about the different colors of blue, but everybody that I talk to, high proportion of people that I talk to, even hardened building professionals, are very surprised that the building sector is the biggest. So this is, new buildings, existing buildings. So what this is telling us all if you look at this third graph, that's us, all in the building sector. If we don't do something about our greenhouse gas mitigation potential, nothing else really matters. So if you just do the simple math and let's say we brought transport down to 0 and we didn't do anything about buildings, we're going to be hooped. So if you're wondering why you're working so hard to try and deliver net zero buildings, this graph you can grab. We've got the reference there. I can send it to you. This is the graph that you use to reassure yourself why you're having sleepless nights and trying to deliver these net zero buildings, and to reassure clients why it's so important that they do that. I think that was all we had on that one, wasn't it, Bilal?
That is true.
And this one is a proper graph. There's no pirates on that one. Okay, off you go.
Awesome. Bilal. All right, thank you, Matt. So no more pirates, promised. It's all serious from this point. So really, we've kind of defined what is net zero and why do we need to achieve this, and the different schemes, or I should say templates, that clients and developers can follow. But really how to do that. And it kind of, at this point in time, it's people are becoming more aware, more educated, but it's always good to remind ourselves of how exactly are the steps to achieve net zero from the design side of things, or the where do you invest your money first. So in any high performance project, even before we speak about net zero, fabric or the building envelope should always come first. And when we talk about building envelope, I would even try to stress on something which is not insulation. Believe it or not, sometimes the shape of the building itself and how you size the mass of the building, how do you orient it, and passive features that you could add is essentially free money when you're trying to sell a service to a client. Or if I'm a developer, I would care first about the mass of the building before I discuss anything about insulation. So that goes really on the left side of my screen right here. We talk about envelope. Things such as improving the insulation, improving the glazing specifications and air tightness. And what that really means is when designing buildings, it's not enough to buy a block of insulation that is R some number and just stamp it there, glue it there into the wall. The details have to be well assessed. It's very good to hire qualified designers and people who understand the details of the building envelope. How do we connect the components? Where should we place our connections? How should we design our balconies? Can we go without balconies? There's a lot of questions that go to the ABCs that, believe it or not, will reduce a lot of the costs that we need to pay in our insulation. So building mass, shape, thermal bridging is the word I was referring to. And then we start looking at the insulation levels. Following that is how many glazings do we want? How much % of the glazing? A typical North American design, and I think really across the globe, developers would love to see all fully glazed buildings. We love to have our tenants, whether it's commercial or residents, to have a picturesque view of the city with a lot of glazing and access of sunlight to the spaces, but that comes at a penalty. So it's always an optimization between aesthetics and actual thermal performance. And remember something, when we're dealing with high performance or net zero standards, often these standards require as built or a 1-year operation of utility bills. So someone is going to really follow up on your energy model or your design, or even better, just like CaGBC zero carbon that Matt introduced, there's a TEDI requirement, which is how much heating the building needs per square meter or square area. Finally, air tightness. Air tightness can be one of the lowest hanging fruits into reducing utility bills or meeting your targets. And that is essentially saying how airtight or how close is the building that we have. Are we allowing infiltration or exfiltration? That's the answer we try to answer. And often we test this after construction with a blower door test. And even before construction, there are mock-ups that are tested. And during design, the architects and the engineers work closely to have details highlighted very well into continuous air barriers and continuous insulation. So that was really about the envelope. And when you have a very good envelope, what people really miss when they jump into HVAC and mechanical systems is that you're gonna buy and purchase much smaller equipment. So for the past maybe 6 years, I'm gonna say even before I was born, we had rules of thumbs of how do you size an HVAC system, and then we multiply a 20% or a 30% oversizing factor, or what we call safety factor. So essentially that shifts the responsibility of client or resident complaints during occupancy, which is good back in time, but today this has to change. So it's a shift in the paradigm and in the mindset that we have toward design. What I'm trying to say is, when you have a good envelope, you right size your HVAC. It'll be a much smaller unit, which means it'll operate at a very good part load performance. It will have a much better part load efficiency. How many systems do we need to buy? How many systems do we need to cascade? What sort of system do we need? Are we going net zero energy or net zero carbon? Do we have enough rooftop area for solar PV or park shading structures to add PV? All of these questions do overlap with the type of mechanical system that we specify. Of course, a good efficiency is unquestionable, but efficiency is a very narrow definition. We need to go outside the box beyond just the number of efficiencies, or COP if you're looking at cooling. Heat recovery is a must, I should say, in every single design decision, but recovering energy and ventilation is paramount to reducing your heating loads, and as well as ensuring adequate air quality or adequate ventilation is being delivered to the space. Because remember something, when you improve the air tightness, that is not allowing infiltration to the space or exfiltration, you're reducing the amount of fresh air inside the space. So there, we need to bring this from outside, but make sure it's treated to reduce the amount of energy. And of course, please do put your questions if I'm going too fast or if I confuse anyone. Lighting and plug loads are very essential if you want to reduce your electric usage, and that is go net zero on site. I believe LEDs are very mature in our market. They're very affordable. And often much electrical designers look at building management systems, you look at daylight controls. We're now speaking in a bit of a higher level of how can we control electric appliances and lightings across the spaces. And often much this conversation is more dependent when we have commercial type of developments, whereby people do not occupy the space all the time. And during unoccupancy, the building can control itself to reduce the wattage or the load on not used equipment. So after we finish this part, which is the left side of my screen, I'm gonna shift to the other slide. And as you see on the right side here right now, we have two ways into looking at absolute net zero on site. Because some people do not want certification. They don't care about certifying a building, but they really care about having high performance building. So the left side of the screen is sufficient. If you want to go to the premium end of building performance, we need to add some sort of renewable energy. That can be on-site renewable energy or off-site renewable energy in case you're in a campus, or sometimes people refer to it as renewable energy credits or carbon credits if you don't have a campus energy and you want to buy purchase credits from outside. I think the metro the structure we have, the city of Calgary, does buy renewable energy from the southern of Alberta. So that's a good example of a model of how we can have assets that are low carbon. There's one question I think that came up here. In light of COVID, can you speak to the effects of increasing?
I was just trying to unmute. So I will just chip in there, Bilal. I was just reading this great question from Daryl. But then what I was going to just say just before I come back to your question there, Daryl, is another key thing at this stage is understanding your client's priorities. So if it's an institutional building or series of buildings, they're probably quite ready to invest in the envelope side of things. If it's a private client and they're looking for short-term profit, they may want to focus their attention in other areas. Sometimes clients just think one particular technology towards net zero is cool. But we've got one project where the client just wants you to drive into the site or walk into the site and just see a massive solar panels over every single available space on the building. And that is the most important thing to this client. So another say, well, I don't want to see anything on there. So finding where that the most comfortable fit, which areas just they're prepared to invest in and which areas just excite them, that's part of the discussion at this stage. So Daryl's just chipped in with a question of air exchanges and infiltration rates, and that definitely comes into it. We do have a couple of slides towards the end that talk to this, but we'll bring this up right now. It is a fantastic question. So one of the key things that we're looking at with clients as they're re-entering the workspace is making sure that they understand what the ventilation strategy is in each of the spaces and what it needs to be. And certainly when you're looking at one of the best measures for reducing that in the second box that you see there in terms of the HVAC is recirculation of air, and the whole idea of the HRV. If you're the mechanical designer, you really need to be guaranteeing the client that you're actually not going to have any cross-contamination. So one of the things we are going to touch on is, as you reduce the air leakage, you're obviously you're gonna need to, you can have less opportunity to dilute any potential contaminants or any airborne particulates or anything like that. So that's a really good question. We were going to touch on that later, but thank you.
Appreciate it, Daryl. Yeah, we'll touch on it.
The next one.
Yes,
then?
I'll carry on, and I'll try to make this a little bit smooth and quick, so we can jump to the other slides. Essentially, what we're looking at the screen is some colorful illustration that has a point, and I want all of us to look at this from the left side to the right side. So currently today, at least I would say in Canada, and it's very similar across the globe, there is some sort of a building code that needs to be followed. And part of that building code is an energy section, an energy jurisdiction, calling for an energy requirement, or sometimes a jurisdiction call for complying with LEED. So I'm speaking about across geographies around the world. But what I'm trying to say, there is some sort of an energy performance target that has to be addressed, or at least discussed, for every design. So at least in Canada, we have the NECB 2017 in most of the provinces today, and 2015 in others. And to achieve this, designers and developers alike are seeing a little bit of a change. And that is what we call in thermal bridging. So today, thermal bridging design cannot be just a small Excel exercise that we used to do with the older edition of the code. Today, we're engaging in a much more structured conversations with the architect and sometimes the design build team. We're looking at more tangible and actionable solutions to reduce thermal bridging, to reduce by the way, I should mention, in case some of us do not know this, thermal bridging is essentially a bypass. So if you have a very good envelope and you have sort of a stud that holds the structure together, that stud is a bridge for heat to transfer from the inside to the outside, or the other way around, depending if you're in a cold or a hot dominant climate. So back to the flow chart, achieving NECB 2017 is becoming the new norm. People are more aware and educated how to do it. It's a really envelope-first approach, and the estimated savings are usually less than what you saw in 2011, but it's attainable. Now, from that point, we do have projects that pursue something additional, such as a LEED certification, a LEED certified building, whether it's a certified all the way to the gold, what we typically see. Obviously, the energy performance is more upgraded on that regards. And this is very similar to projects, residential ones that are pursuing CMHC funding. So in that scheme or that funding, projects have to achieve 25 or 15% above the NECB 2015 edition. So it's still an investment in systems and as well envelope, but we see an interest and uptake in that, not only from the client side of things, but also the designer side, that it's becoming more attainable and more logical and more reasonable to achieve them. So I want all of us...
Just on the CMHC funding, chipping back to what we were saying at the beginning, there are different requirements for energy and carbon for different streams of CMHC funding. So they're not all the same as well.
That is true, Matt. So some of them...
being clear on what your target is and what the requirement is.
Absolutely. Some of them are for renovations and retrofits, and some of them are for new construction. So again, back to Matt, I think you mentioned this twice, and it's important to understand what the client wants and really what the authority is looking for. It gets more interesting with this flowchart when we look at the middle, where it says high performance near zero energy in dark blue. So right there is a little bit of a pathway, and we ask a question: do we need to attain a certification to go with the premium net zero, or should we just want a building that has a longevity in its assets? It has low operational and management and utility costs, and that's I would say the two pathways that we could go. A near zero or high performance building is very self-defined, but it does take a little bit more in terms of design and involvement for what you do for a LEED. Things like that involve a little bit of penalty, or I should say penalty, but accepting the fact that you would need less amount of windows, you would need more insulation, you would need more sophisticated type of controls. But at that point, it'll be very easy for projects to pursue different certifications. So just like we defined earlier, the zero carbon, the ILFI net zero, and the passive house. You will notice what I did there is that each of those will have its own requirement. So if you achieve passive house, it doesn't really go synonym to say that it will achieve zero carbon, and vice versa. So we can neither deny nor confirm, but what I'm trying to explain is if you achieve one of them, it doesn't mean that the others will be accepted. So there is a bit of admin work and some extra documentation that the rating system requires. But I guess the sentiment is all of those will have very low energy use intensity and very low heat use intensity, and hence you would need to invest in a less amount of solar than a near zero building, or less amount of renewable energy to achieve an absolute net zero. But the message I want to convey in this flowchart is optimal massing becomes more crucial as you go with a low energy building. And when massing, as I explained, it's how does a building look like? What sort of balconies do we have? What sort of thermal bridging are we accounting for, as well as air tightness? I'm happy to take this offline in case anyone is interested to see more details on that, or I'll just wait for questions. So I'm going to pause here for a minute in case people are typing. And I will just briefly go over the study that we have delivered last year. In this study,
I think we should let me just briefly touch on these next two, just to make sure we finish on time and then see if there's any questions at the end, because we got quite a lot in the last few slides, I think. Yep. So if that's okay, I think all you need to know about this one, it was a study that that Bilal did in terms of, we were asked to model how you achieve two of these main different versions of net zero for different building archetypes. And we went through and we did actual models, and we did them for all the different climate zones. So I think this is available online, I think, through Alberta Infrastructure, so we can circulate it. So I don't think we'll go through necessarily every single detail here, unless we want, maybe we can at the end if there's time. But what we found is that we just picked and chose different solutions for different building types and different locations. And so there is assistance that's out there. I believe that is still available on the Alberta Infrastructure website. That's quite a big study. So we want to show that there are suggested solutions out there, if that's okay. I think just so we can get into the depth on some of the other ones. And then if that's okay, Bilal?
Oh yeah, absolutely.
Yeah. And then the next one, we just want to illustrate, here's another example of something that we did the mechanical, electrical, and energy modeling design on. It's a building in one of the coldest parts of Alberta, and it's Passive House certified. That's right, or Passive House Plus?
I think it's a Passive House Plus, yes. And
this has achieved all these metrics that we're talking about, usually listed there, and it's really a groundbreaking building that is that we're very proud of. We can go into the details there. So
just to chip in very quickly about the client, the town of Valley View, they were between two decisions, and there are two options. A, should we retrofit the building that we currently have and make major renovations, or B, should we just go with a complete new construction that is passive house and reduce our operation costs? And when you look at the 30-year period or 35 years period for the life cycle cost of the building, it made much more sense to pursue passive house. So this was by the client, and I think it's a very interesting case study for Alberta for all of us here to realize.
Okay. Over to you, Bilal.
Sorry, I was on mute. So just for the courtesy of time, I'm happy to share those later on. But the message we want to convey is passive house doesn't really mean a lot of extra costs. We are looking at cost premiums in the Alberta climate zone. And when I say Alberta climate zone, it's a cold climate zone. Unlike British Columbia, our neighbors, typically it might be a little bit more cost affordable or we have faster return on investment in BC, but in Alberta, we're looking at cost premium between 5 to 10%. And of course, this can really be subjective on the type of the building, as Matt explained. Is it residential, institutional, commercial? And what type of rating system you're pursuing? And what is the financial model? Is there financing happening? And is there something that we could get economies of scale for? Payback period is about 20 to 25 years. So owners would need to know, are they owning the building across its life cycle? Are they selling it after 10 years? It's all of the accounting and financial questions that need to be asked before we formulate the full business case of Passive House. So I just want to end it there for courtesy of time, but we can address questions even offline after that. 2020, Matt?
Did we skip the more detailed one for the case study? Was there a slide before that last one?
Yeah,
that one?
it's this
Did
one.
we skip that one?
We did skip it in,
I think this one's
in lieu of the other.
I think this
Yep.
one's worth having a quick chat about. Did you want to talk about this one, or shall I? So, I'll start off on this one.
Yep.
So, as part of this study, which was a lot of fun, but we actually looked at the three in Alberta. It was an Alberta-specific study, and then you'll see on the first column on the left, we ended up selecting 3 representative building types. So what we did is we took 3 projects that were just there with no ambition other than kind of meeting code, or actually, no, that's incorrect. That's meeting the minimum Alberta infrastructure requirements, which was roughly analogous to 12 lead energy points. So we took that as a baseline. So it's a good building as a baseline. And then we this is where, design and energy modeling is as much as an art as a science. So we picked what we thought was a very sensible set of measures. And we actually were very conservative with our choices. We didn't go with anything particularly exotic. We didn't go with any products or any solutions that would require importing from outside of Canada, or we went with things we knew were available. And then we had everything independently costed. And this is just, we repeated this for the ILFI net zero standard as well. And what was interesting here is that it came up fairly consistently. And then we also, in terms of the estimated cost premium, and we also had this kind of verified in other studies, whereas the cost premium of net zero tends to come down to kind of like in that 5% range. For the smaller multifamily residential on another study, it seemed to come up, we saw as much as I think 15%. Is that right, Bilal?
That is true, yeah.
But then the other thing that's interesting here in terms of big picture, which I think I'll talk about now, if that's okay, Bilal, is the whole idea of electrification. So one of the things you have to do with the CaGBC zero carbon standard is show that you've got a route to having no combustion on site. With the ILFI standard, you have to have no combustion on site straight out the gate. So once you start making a building fully electric, so you have no gas consumption on site, it leads to another set of design challenges. And my eyes were opened when I was in a workshop talking about electrifying quite a large municipal building. And once you get to a certain size of electrical cable coming in, you actually have to put it inside a concrete bunker. And so you actually have to start changing the transformers and actually changing the structure of the building. So the other thing to bear in mind in net zero is when you start to look at the whole of the province, do we lean on a greener grid, and that expectation come as we move forward, and do we start to electrify everything? But that's a much bigger conversation. Okay, back to you, Bilal. Sorry, unless I missed anything there.
No, absolutely, thank you. And back to that argument, of course, electrical costs and mechanical costs would shift. You're really shifting the cost from piping into cabling. You'll be surprised. It depends what sort of system you do. But the whole concept of net zero, it's about cost shifting, all right? You're removing it from the cost of mechanical. It'll be much smaller, and you're investing it in envelope. And when we talk about electrification, we're moving a plumbing-ish type of costing into more cabling and electrical and bus bars that has to be in the facility you're considering. So thanks for that, Shine and Matt. I have a one slider very briefly to talk about the NACB 2020. This is nothing secret. It's out there for public review on NRCan's website. I'll attend the question in a minute by Ursula. The point here, I just want to very briefly to look at the staircase graph that we see. On the left, it indicates 1997. That's when we had the MNECB Energy Code first published for Canadian jurisdictions. And today, as we speak, we are in the 2017 edition. So the trend is very obvious. It's a staircase going downwards, which means energy code will only become more stringent. And it's up to us if we want to ride this wave early and adapt to it and start getting more familiar. And because with the 2020, the energy code requirement is just going to become more difficult on paper. But granted, the design, I think we have a very good talents across the country, and we've been involved in a lot of net zero projects. So it's we're totally excited for this new energy code, and especially right now, it'll be introducing a tier system similar to, for of us who are familiar with the BC step code, step 1, 2, 3, 4. Something similar will be in tiers for the NACB 2020. We're not sure yet which buildings should pursue what sort of tier, but we know that it'll be structured. So in case we want to talk about near zero or high performance, we have now a benchmark that we could always refer to instead of just generic near zero terminology, so which keeps all of us on the same page. One of the biggest changes I've realized in NACB 2020 is just, of course, our values are becoming higher that we need to compete against, and as well as an air tightness testing requirement, as I understand right now, but correct me if I'm wrong, Matt. So the focus on the air barrier and air tightness for the first time has been now introduced to the energy modeling performance pathway. I really want to end it here with a slide, unless you want to bring any additional thoughts, Matt.
Oh, okay. I really wanted to do the next slide because that one kind of blew my mind. But well, let's ask, I just typed quickly back to Ursula's question. So the geo exchange, or I think, or the ground source heat pumps are a really nice technology. They're fairly simple. You could obviously get different types. You can get air source heat pumps, which have a challenge in our winter. You can get the vertical boards, you can get the slinky boards, slinky type where they kind of go more horizontal. And they can be a great part of a solution. Going back to my thing with the pirates and people saying, well, if you put this in the building, it's going to make it greener. We like to model the building as a whole system. So I'm always looking at what's the next best alternative. So if you're going to go for an all electric building, ground source heat pumps are going to be right up there as a really good choice. What's interesting is looking at the timeline, and this comes back to defining what the client wants to do. If you were to just do a straight swap right now for ground source heat pumps, the COP, the coefficient of performance of the heat pumps, is fairly much about the same number as how much CO2 is emitted from 1 kilowatt hour of Alberta's grid electricity compared to 1 kilowatt hour of heating from natural gas. So right now, at this moment in time, it doesn't get you much further in terms of your overall CO2 emissions for the building, but it puts you in that position to be an all-electric building and have fewer local emissions. So hopefully that answers the question okay. So yes, but there are very few things which I think are a fix-all silver bullet. So if we're putting geo exchange or ground source heat pumps in as an overall strategy, combined with a good envelope, I have heard someone say live in a meeting to a client, don't worry about the envelope, we'll just put more ground source heat pumps in. And to me, that's just not the way to go. You kind of invest in the passive systems. I love this graph. Did you want me to do this one, Bilal?
Please do the honor, of course.
Okay, so this was the first of the studies we did for the Alberta infrastructure. And we were asked to look at what happens to building performance over time, as in we know that climate change is a real thing. So what actually happens to buildings over the rest of the century? So if we just look at this just pick this Fort McMurray building here. So with the blue line is what is called the RCP 4.5 scenario. And that is the amount of heat we're expecting the atmosphere to experience. And RCP 8.5 is kind of the extreme one. So what we're seeing is that in the red line, which was where we're at now, we're seeing that's the heating degree days and the cooling degree days, and we're seeing every climate zone is essentially moving further south. So this was right at the beginning of the study, and it just blew my mind. So if you're designing a building now for a client and you're in Fort McMurray, you know, towards the end of the century, he's probably going to be more like in Edmonton. So we saw this trend, you know, and I was having this conversation with a client yesterday. You know, the buildings in Calgary right now, they're going to keep the building for at least 50 years. And I'm saying, well, in about 20 years, your building's going to effectively be in Medicine Hat. So if you want it to keep running efficiently and effectively, you're going to need to look at how you might upgrade those systems. So I did want to do that one, and then whether you put up the last, let's do this one, because we had a great question about this one here. Did you want to talk through this one? And then we got a couple of great questions.
Yeah, very briefly. So you notice, everyone, the last two slides kind of zoom out outside our discussion to look into the nexus into climate change. How does your net zero building operate in the next 30 years, as well as the escalation in utility rates, which was not in the slides, but the cost of energy is probably going to escalate in the next 10, 20, and 30 years. So when you're calculating your investment or return on investment, you have to capture the life cycle and not just next year's. Finally, with this slide is a little bit harmonious with what I was explaining earlier. I have two graphs here, or two bars. One is green, which is good, and one is orange, which is bad. The good and the bad is the air quality in a space. And what the message is here right now is the air tightness of the building in terms of ACH, or air changes per hour. At 1.3 is a not so good air tightness, which means that air does infiltrate through the windows or openings or non-continuous barriers. When that happens, the purple, and I would say, let me say dark and light purple in that case, both look purple to me. The infiltration, as we increase the air tightness by halving it or reducing it from 1.3 to 0.6, the amount of infiltration reduces significantly. This will save a lot of heating energy, but the amount of fresh air available per person is also reduced. So to de-risk this fact, and now we're in all of this COVID scenarios these days, we need to think about the air quality of the space. We need to reintroduce that deficit through fresh air handling units. And the question that was raised earlier is, what do we do right now given the COVID? There is an energy penalty, and we all know that for sure. But it's time to rethink a little bit about how do we place people across spaces. We don't want densely occupied spaces anymore. We need to have better filters that are replaced frequently. We need to make sure our energy recovery is working properly and avoiding cross-contamination. I'm gonna apologize to go very fast with this, and then maybe open up the questions in the Q&A. So Matt, if you've seen a few questions, that'll be a good time to bring them up.
Oh yeah, I've got a question from Jeff, and then there's one from David. So Jeff was asking about micro CHP, and we just right at the final stage of completing a study for the City of Calgary on a particular development. And one of the things they asked us to look at for that was what opportunities are there for not only just the micro CHP, but they asked us to look at, as part of the permitting requirements, look at what other facilities are around. So the success for any form of CHP or cogeneration for me is linked to obviously two things. One is what can you do with the heat, and the other one is who's going to operate it. So there are lots of technically excellent examples of CHP and micro generation around the world, where they've been a technically good solution, but the operator has not had the skills, so therefore they've been mothballed. So when I'm starting to look at that, I'm saying, well, can we size a system to obviously use all the excess heat, but also who's going to maintain these things, and is it in the and what's the long-term goals? So in the study we're just finishing off actually the final meeting for that one today, micro CHP came out as a really, really strong measure for reducing the overall GHG of the project. So it's a little bit of a consultant answer there, Jeff, but it kind of depends on the specific circumstances. So hopefully that's okay. And then we've got another couple of questions here, have we? Oh, okay. David has asked, how limiting is the current carbon intensity of Alberta's energy grid to achieving net zero building design? Is renewable energy procurement a large or manageable obstacle? Okay, I do love that question. There's a fantastic book called Energy Without the Hot Air, which is free online, which actually leads you to this conclusion that the way to deal with everything is electrification of everything, and then we can deal with the grid. So we are gradually phasing out coal in Alberta, and we're moving towards a cleaner grid. There have been a couple of big examples of quite large PV arrays being installed, many megawatts. So in terms, we've got two options. One is we can proceed on the basis that the grid is going to be greener, and we can actually move down electrification and say let's proceed on the basis that that's gonna happen and can continue to happen. And the other thing is we can say let's move down the direction when we're not going to clean up our grid, and maybe it actually gets dirtier. So let's look at our buildings as net zero on their own. So either way, by reducing the loads and making the building envelopes better and making the systems better, we're going to contribute towards that. One school of thought is also just concentrate on primary energy. So you can't actually affect as an individual project what's happening on the grid. So just make your building as good as you can. Hopefully that answers your question. Okay. Okay. Ahmad has got this question. Ahmad Maroof, are you related? No.
Actually, I'm honored to have my father here on the chat.
Is
so
this your father?
That was quite a surprise. Yes.
Oh, fantastic. Well, it's a pleasure to meet you online. Well, I think you should answer this question, Bilal.
All right, let me take the honor. How much improvement can be done in the indoor air quality in green buildings? I bet you've intended to ask a very difficult question. Green buildings are intended to be healthy as well, which you briefly touched on. And health and environmental quality looks at acoustics, looks at ventilation, looks at thermal comfort, views, daylight, as well as the adequate air quality. So the answer by default, it should have an improvement in air quality. But again, the devil is in the details. And the answer is, how well was a building designed? Was it constructed to the standard or to the specifications? And finally, is it operating? And Matt stressed on that a couple of times today. Are the facility managers looking at that building that it's operating to standard? Is a very big question to be answered, especially in the realm of COVID-19 that we live in today. I hope that answers the question.
Okay, we've just got one more question, guys, from Andrew. If you wouldn't mind taking this one pretty quickly, and then I think we're almost out of time. So the question is, for the climate zone in the Bow Valley Canmore area, does Integral have a recommended A, most cost-effective net zero energy wall assembly, and B, most cost-effective net zero carbon wall assembly? So net zero energy and net zero carbon.
Maybe I could briefly touch on this. So there is a study that shows a map of the entirety of Canada, all climate zones, on the recommended R values for wall, roof, and floor, and internal partitions across different jurisdictions onto achieving net zero. That was for residential. So the answer is, I would be lying if I say what is the most cost effective, because it really depends on the building. For example, if we are doing a warehouse, you're going to have much more roof relative to the wall area. If I'm doing a mid-rise towers, you're going to have more walls relative to the roof area. So the R20 in a warehouse is not the same as an R20 in a mid-rise tower. So although it's the same number, but how much yield or how much benefit does it give you? It really depends on the type, shape, and the, I would say, business hours of the building. Typically speaking, in Alberta, we're looking at numbers closer to the at least R25 numbers all the way to the upper R35. The Valley View case study over there, I think it had a close to possibly R45 wall. So it really depends on the type of the building, and I would vouch against going with the rule of thumb or most cost effective, because we try to go with what works for everything. But again, it's a very design dependent and a building dependent question that has to be addressed uniquely for each project. Sorry if this was a yes/no answer, but I'm trying to be
No,
a little bit real.
I love that question as well. We're working on an institutional building in the area, which is going to have a lot of vehicles coming in and out of it. So, you know, maybe you can't achieve air tightness in that part of the building. So you need to look at, you know, perhaps radiant heating systems. So you're heating the people and you're allowed to have the air changes because you're going to have the doors open and things like that. And also there's a big difference if you're doing like a light industrial unit. That's where those clients will spend money on the roof anyway. So they will be spending a massive part of their budget on the roof as that's such an important part of the building. They're quite happy to invest more in the roof, whereas they recognise that maybe the walls and the roof, the walls and the doors, they're going to have quite a high repair rate anyway. So it is unfortunately very contextual, exactly as Bilal said.
Okay, thank you guys. So just before we close up here, I just want to let everyone know that when they exit out of the webinar, a survey is going to pop up, and I'm just going to very quickly ask people if they wouldn't mind taking 5 minutes out of their day to complete the survey. The idea is that we are going to analyze the results of people's learning and use this information to create bigger and better webinar series and hopefully in-person events as we move forward. And the survey will help us ultimately apply for additional funding because we can prove how effective we've been with these conversations. And finally, just before we go, I wanted to let everyone know that next week we have Dale Mickelson from university back on the screen, and he's going to be walking you through some actual examples of leading edge high performance buildings in the university area, some of which he touched on during his keynote presentation, but he's definitely going to take a deep dive into some of the things that Matt and Bilal have touched on today. And thank you everyone for coming. Don't forget to check out the online trade showcase, and I look forward to seeing you all next week. Thank you very much and have a great rest of your day.
Bye.
Cheers. Bye-bye.